Prova, prova. Si sente bene? Sì? Boh, ok. Spero di non urlare o parlare troppo a bassa voce, in caso mi fate un segno. So, switching actually to English, hope everybody is fine with that. First of all, thank you very much for joining and for being here today. Actually, it's our first time at the Motor Valley Fest, and we are very much excited to be here with all of you. I'm not going to spoil too much of our agenda, but you're going to discover more about Tesla today and why we are here. I would like to thank everybody. Maybe we can start introducing ourselves. I am Adelina. I'm originally coming from Romania, but I've been living most of my life in Italy, so it's good to be back to Italy. We felt very welcome here in Modena, I would say. And yeah, I studied business administration at the University of Brescia. Then I started working in the human resources area, and 2 years ago I moved to Berlin, and I joined Tesla as an IT engineering recruiter. I joined the Gigafactory. I would pass it to my colleague Lea.
Yeah. Hello everyone, very nice to be here in Italy. I'm originally from Germany and I'm Lea. And here you can also see QR codes on the screen, and those are our LinkedIn profiles, so in case you want to connect with us, just scan the QR code. And yes, I studied intercultural business psychology, also in Germany. Then I've been to London for 2 years for recruitment consultancy. And then in 2020, I joined the journey at Tesla and started as one of the first 100 employees at Gigafactory Berlin-Brandenburg. And yeah, very excited to speak about that today. And also, we are really open to interact with you today. And I'm hiring mainly for battery cell positions. And Mattia also has a team that I'm hiring for, the drive unit team. And he will also introduce himself now.
Thanks. I'm from design engineering at Tesla since 2020. I'm originally from Italy, and I'm very excited to be here today for 3 good reasons. That going home is always nice. The second one is my love for automotive comes from the red car you guys build around here since I'm a baby. And the third one, that my professional journey in this field started around here with an internship during my master in Reggio Emilia. So glad to be here today. And we are going to talk for about 1 hour, a bit less. But if you should take home one message from us is what Tesla is all about and how you can contribute to our mission. So we will start with a very short video introduction.
Yes, when I see this acceleration, I always have to think about when I was driving a Tesla for the first time, and I almost got stomach ache. But yeah, this is one of the things I really love about Tesla. And there are two more things that I really love about Tesla and more, but I will not tell all of them today. And one is also that we have a lot of stories behind our product and also behind our logo. And second thing is that we love interaction in presentations. So it would be really nice to hear your voice today as well. And that is why we have some questions in between. And you will also win a prize in case you can answer the question. And the first question would be, do you know why our Tesla logo looks like that? Any idea? Ah, yes, please. Very good. So prize goes to you. Yes, exactly. So the Tesla logo is representing a part of the electric motor. Specifically, the bottom part of the T is related to the rotor of the motor, and the top part, the stator of the motor. And it's very similar also with SpaceX, that there's a relation to the product, to the mission, because that is also showing a rocket trajectory.
So, what about our mission? First of all, there will be more questions, so your colleague was great. There are 3 more prizes, 3 more questions, be ready. Our mission is to accelerate the world's transition to sustainable energy, but that doesn't sound it has a lot to do with cars. So we need to do a bit of step back to understand how we went from building cars to this. The logo Lea presented was Tesla Motors, which when it was founded was aiming to accelerate the world transition to sustainable transport. That was our master plan part 1, to make an electric sport car to show that electric cars can also be fun and performing, not some ugly cartoon stuff. With that, then go to a cheaper car, family sport car like Model S, and with the profit generated, then build an even more affordable car that was Model 3 in 2017. Then Master Plan 1 was completed, but we are still 10 years in the past. So there was Master Plan Part 2, and that's when Autopilot was introduced. And now we are dealing with Master Plan Part 3, where the ultimate goal is to switch entirely energy consumption and transport, as well as heating, to renewable energy. So the cars are only a part of it, and the plan got much more ambitious. This said, the only way to achieve this is with our products. And
all right. So before maybe jumping into the new products as well, maybe you can see here the blue car, which is the last one here. Just for you to know, this is the only car at the moment that we are producing at the Gigafactory in Berlin-Brandenburg area. Then we have the Cybertruck. Probably you have heard from the news that it's the latest model we recently launched. Then, of course, the ATV, the Roadster, and the semi-truck. But considering that we want to accelerate the world's transition to sustainable energy, Tesla started to focus as well on some other products, so some residential and on commercial products. One of them is the Powerwall. The Powerwall was introduced in 2016, and that's a home battery storage solution for storing the energy basically in our houses. Then in 2016, we introduced solar roofs and panels, and those are both for commercial as well as residential use in order for, to store the energy to our houses as well. Well, we have a hot question for you now. Let's see if and who is going to get it right. Does any of you know why the cars are parked in this sequence? Oh, I see so many hands. Guys, I have no idea who was someone from here. I've seen the first hand. I think the guy with the red shirt, maybe?
Well, it spells sexy.
It spells sexy, yes, that's correct, exactly. Yes, absolutely, because we produce sexy cars, that's a fact. And another maybe fun fact that we can say is that Ford took the Model E trademark and they killed Tesla's sex drive because, yeah, they took the Model E and that's how we ended up with Model 3 instead of Model E. So hope you enjoy the fact and happy to see some people that knew it already.
Yes, we do not only produce and sell sexy cars, we also have some other sexy products. And yeah, here you can see 3 of them. The first one is the Mega Pack. So this is like the power wall storing energy, but for industrial use. And you can also see there the supercharger and the wall connector. And we are proud to say that at Gigafactory Berlin-Brandenburg, we have over 500 wall connectors. And we also we think we have the largest charging car park in Europe. We haven't heard of a bigger one yet, at least. And yet, to produce those products that we were just speaking about, we need factories as well. So here are 4 of them. The first one is in Fremont, where we have produced all models, so Model S, 3, X, and Y. And this one also still in production stage. Then we have our gigafactories. The first gigafactory is the one in Nevada in the US, mainly for powertrain production, so battery and drive unit. The second one in New York, mainly for photovoltaic manufacturing. The third one is the first one outside of the US, so that's Giga Shanghai, where we also have car production in China. And the fourth one, so this is the one where we are all working at, Gigafactory Berlin-Brandenburg, where we are producing a Model Y, and yeah, having all part of the car really produced in one place. And the fifth one is Gigafactory in Austin. So this is our headquarter now. And this is also home of Cybertruck. And you will also learn more about Cybertruck later. And recently, we are ready for a prize again. Recently, we have also announced the 6th Gigafactory. And I wanted to ask you, do you know where this one is going to be located? Yes. Yes, please. Yeah.
Mexico.
Mexico, correct. So next prize goes to you. Yeah.
But today is not about the Mexico factory. It's about Giga Berlin, the jewel of Germany, as Elon tweeted, or X. And there is a short video now, again, I'm the video guy, of a drone footage. There is no audio, so don't worry. It's a drone footage, a real one, shot flying inside our factory. And we go through the different shops that at the end compose the steps that will result in a beautiful Model Y. Right now we are in casting. Casting means you take molten aluminum, you press it, 6,000 tons, like 1,000 elephants, sit on top of it until we get it to shape. We have the Giga press, actually from Italy, that builds the front and the rear casting part that would otherwise be built with several smaller stamp parts that need to be connected together. So big simplification to the process. Then we already went through stamping, which you take a sheet metal, you press it, and then you get the contours and the shapes to form the sides of the car that you see here, the doors. Then you get to body in white, where those are together. Body in white does the name because the car is not painted yet. Paint happens with this spray machine, but also with some swimming pool baths that apply more than 10 layers of paint as thin as a human hair to get Model Ys in black, white, blue, midnight cherry red, and quicksilver. That's the color we produce in Berlin. And that's how the car looks like after paint. It's not all made of metal, some parts are made of plastic. So we will have also plastic molding and plastic painting with the same colors of the car. This process is something in between the 100-year-old Henry Ford step-by-step process and what Tesla called the unboxing of the car manufacturing, where the car is not like growing step by step, such that you carry all the components through a huge flow that can never be interrupted, but smaller parts are built together with a greater space and time efficiency, and only once at the end the different parts of the car are assembled. So towards that direction to reduce our factory footprint and the cost. You saw only the outer part of the car so far, but I mean, the core of Tesla, and also where I come from, is this business of drive unit and powertrain. In-house, we manufacture our battery packs and cells that Lea will talk about later, and also our drive unit, which ultimately is what moves the car. You first saw the stator in the hairpin winding, and now you're seeing the gear train assembly. Once this is all together, you get the full drive unit, which is basically the equivalent of the motor for a combustion car. It's tested at the test bench, is joined to the battery pack, and then at the marriage station, probably the most exciting step, the chassis that came from the first part of the video and the powertrain from the second one get joined together, and then some last assembly steps are conducted in general assembly, like the wheels you see here, as well as the gaps and the glasses and the doors, until the car runs through quality control with the LED tunnel, which was made famous by Elon, and it's also a pretty popular spot for pictures of visitors at Tesla. Then the car is ready, but you didn't see everything in the video. So Lea will tell you a bit more about what was not there. Before that, last question. Show. So there is a 6 on this t-shirt, okay? So something like 6,000, already a little hint. Do you know what's this t-shirt celebrating, or what could it be celebrating? And that's the same t-shirt those people there are wearing next to the LED tunnel. You got to try? 6,000 cars produced, not faster per week, yes. So thank you. Last award, we will have some other presents later, but no more questions.
Yes, there were 2 shops not mentioned in the video, the battery cell shop and battery cell assembly. And the battery cell production is a very new innovative production. We are producing the 4680 battery cell, where 46 is the diameter and 80 is the length of the cell. And this battery cell has a 5 times higher capacity than a conventional battery cell. And in battery assembly, all the cells are coming together, and this is then a very important part of the structure of the car as well. And within all those shops, we have many opportunities. So from process engineering, equipment engineering, controls engineering of the machines, and also in development. For example, battery cell development for mechanical design or electrical design, the same for drive unit as well. And yeah, also to keep Gigafactory alive, we also have many support functions, and Adelina will tell more about that.
Yep, so among the supporting functions, we have the IT department. It's a pretty big one. They are divided between, I'd say, our offices and the manufacturing shop floor. They support and they provide a connection to the robots, those that are actually building the cars in the manufacturing shop floor. We have some hundreds, for sure more than 400 or 500. And as well, just to give you some numbers, they provided the network connection cables that, if we count, would be more than 500 kilometers. And they also provided the IT equipment for some thousand of employees that we are at Giga Berlin. Probably some exciting facts about our IT is that most of the softwares and applications are built in-house, and they're also open source. I think I didn't mention at the beginning, but I mostly hire for the IT and engineering department, and we mostly look after, I would say, software engineers, front-end, back-end, data scientists, analysts, and so on and so on. So it's mostly, I'd say, IT. Then we have the environmental health and safety department. They oversee more than, I'd say, 300 hectares where we are in Berlin, and they not only guard and take care of our factory, but they also ensure a safe environment for more than, I would say, 12,000 employees we are already at Giga Berlin, and as well as information. Then we have the quality team. The quality team plays an essential role in the car manufacturing, from the design until the general assembly of the car. So they basically need to put the final stamp on the quality of the product before it gets out of the factory. We also have the new product introduction. This team introduces and manages the, I would say, new product, the innovation across all the teams at Giga Berlin, and they also support the ramp up of the factory. Nevertheless, we also have our logistics and procurement teams. Those teams need to ensure that the right materials are going to the right place within the right timing, and they provide the specific materials in order to be able to build the cars in a timely manner. The construction as well and the facilities, we have our own construction teams, and they basically design and build all the facilities that we have at Giga Berlin, and yeah, they ensure as well that the whole infrastructure and the traffic works as foreseen. And last but not least, actually, we have two more. The Human Resources Department, we like to call it People's Team. That's where Leah and I are coming from. And our teams, I would say, managed to onboard more than 12,000 people in around 3 years, which is pretty impressive also for Germany as well. And I would give it to Mattia to talk more about the design engineering teams.
Yep. This was the last transition we did, and we always managed with the microphone to get it right. And that was the thing we were the most scared about. So good job, team. The second thing was the video, not to play right. So thanks also to organization to get everything smooth. This is now the last section where I will talk about design engineering in Giga Berlin, because I bet some of you are from engineering, so might be interested in learning what you could do there, how your job could look like. Design engineering in Giga is not so popular because the main use are made by the production of the vehicle, and that's it. It started as a Gigafactory, so to produce the cars. Then figure out that some design engineer would be useful to have somebody on site that knows the product and could troubleshoot when needed. But then the talent pool in Europe was crazy good. You are part of it. And so we grew to hundreds of people, divided mostly in two teams. One is the vehicle engineering team, where everything about vehicle dynamics, interior, exterior, chassis, suspension, aerodynamic, is designed. And the other one is where I belong, which is the powertrain development. It deals with the power flow from the energy stored in the cell until it's converted to mechanical spinning the wheels. Teams that you here are the products, but as well team. So from the cell with the chemical energy in the battery, which is quite some mechanical challenges as well, the high voltage distribution to bring the power from the battery to the drive unit, and then the drive inverter and the drive system engineering, which form the drive unit, is the red component that you see front and rear of the car, where I work. Little quiz, just for us. How many of you from engineering? All of you? Great. How many mechanical? How many electrical? Others? Don't go to university? No, okay. You seen the video before. That's a snapshot of it when we were building the stator. That's because we manufacture it in-house, but we also design it in-house. So the full chain of hardware development, very beginning to the very end. You sketch it on the paper, you see a car coming out with it. The drive unit, the red thing that moves the wheels, getting the energy from the battery, it's made of 3 components. The inverter on the left to convert the energy, then the stator and the rotor to form the electric motor, and the gear train with the differential. Tesla, if you didn't drive one, I recommend you do, but like most electric cars don't have a gear shift, but there is a gear train because the speed at which the rotor rotates is much different than the one the wheel needs to rotate at, so there is some constant reduction and the differential. When I said from paper to full production, that's how it looks like for the drive unit. So you start from multi-physics simulations that involve electromechanical, thermal, and magnetic challenges to design the full drive unit. Components, if for the mechanical engineer, might be more familiar with the CAD drawing, and the electrical one with the PCB. So that's not all what we do. We will talk about it later. And finally, performance validation. Some colleague from SpaceX, the CEO, said if you don't fail in validation, you will fail in the field. So testing the drive unit on the bench, but also testing the subcomponents. Here you see our traction inverter just powered on the bench. In my team, we developed the traction inverter at Tesla. I didn't mention, but we do collaborate with our counterpart team in the US, where all these products are developed together. The inverter I will use it just as a case study to show you how one of you could work at Tesla, what they could do. I could have picked any components, but I like this the most because it's what I do. And I briefly introduce what it does for those of you not familiar, and then I will present how is the day-to-day work and challenges about it. So the inverter takes through that orange cable in the picture, but also in reality, the DC power from the battery, then transforms it in alternate current to power the motor. With alternate current that flows through the stator windings, we generate an electromagnetic fields that spins the rotor, then the rotor is connected to the gears, to the shaft, to the wheels, and ultimately the car moves. This is done depending on the instruction that can come from the human who drives the car, but as well from the driverless. Are some of you in the Formula student? Yay, that's the best bribe. And so you know about that, and depending on what the signal is, then the inverter will be able to provide more or less torque, ultimately become speed, and then move the car. Like every product design, there is something you want to achieve and some challenges you face. The performance index of the inverter, the main one, is the efficiency. This is measured in percentage, and it's then translated to watt-hour per kilometer. That's how much energy you need to move the car for a certain distance, and that's the equivalent of the kilometer per liter of combustion cars. In the graph, you see that we are doing pretty well there. It's not just about the drive unit, it's a whole system that needs to work for it. And the other key performance index is the peak power. In a combustion car would be the horsepower, I cavalli. In an electric motor, usually measured in kilowatt, and then becomes Newton meter, so the torque you can apply at the wheel to then accelerate the car, which ultimately translates in some fast, sub 2 seconds, 0-100 time. Of course, it's not hard to achieve something like this if in vacuum, but when your design space is limited by different constraints that can that can come from all the challenges down here, then that's where it becomes the challenge of good engineering to make a good product. Reliability is, of course, key because nobody likes the cars to stop. And if you think you have millions of cars in the world driving many kilometers a day, then when the failures is 1 in billion hour driven, it's already quite relevant. So that's the kind of metric we are looking for. In cost, instead, something which might not be super obvious for just after studies that I learned on the job. It's not just the sum of the components that make up the inverter, so the sum of the bill of material. There is something more to that. There is the system cost, and it's, for example, if you make a drive unit which is more efficient, then you will, maybe it costs a bit more money, but then you will save a lot on the battery, so you can run this kind of optimization to make a best product. And we can do that because we design all the product in-house, so there is not a lot of supplier communication involved that needs to make some product that then it makes every customer happy. We do everything ourselves, so it just needs to work for us, and we can tailor it to our specs. Manufacturing cost, it means if you want to build 6,000 cars a week, then you can compute how many per second, or how many seconds per car, sorry. And then if you do that all over the world, if your assembly steps are efficient, takes a little space and little time, that's very important. And that's where the cycle time and footprint come from. Last but not least, they are very linked together, the power density and the cooling. A typical drive unit can easily achieve 200 kilowatt, and if it has an efficiency of 90%, then you have 20 kilowatt to dissipate in a not so large volume. So it's quite a cooling challenge for the mechanical engineers at the system level. That's my team, which might be watching us from the streaming online. So we say hi, hi. And what we do every day, starting from the component design for the mechanical engineers. Again, the challenges are mostly thermal with the heatsink, as well as designing of the case, the connector, and the bus bars that connect the different components. And in terms of the manufacturing, they then follow mostly the assembly steps. So they think how the inverter should look like, such that it can also be built, manufactured quickly, efficiently. The electrical engineers, the component design is the PCB, as you saw it before, but not only. There is also the power stage, integrated circuits that go on it. When we start from the design, it might be on the paper, but more professionally with simulation and modeling tools, as well as prototyping and testing of the different parts to then put it together and validate the system. And another interesting aspect of the job is that we also work to analyze the failures from the field, from the line, so that these learnings, we can put them together and develop next generation product, which really leverage what we learn every day on the job. So Tesla doesn't really have an R&D team formally in these kind of products. So it's us from the design team that, with the learnings from the field, develop concepts that really would help the company gain something in this multidimensional space and move forward. Two of them I present here. One is particularly dear to my heart because it's what I started with at Tesla, with the project with the reduction of silicon carbide, and shows also how somebody in a short amount of time can have an impact on a product that really goes on the road. And the second, the reduction of rare earths in the rotor. Together, they show how we do develop next generation products with the challenges in mind that we need to solve every day. So for example, reducing the need and the consumption of materials which are hard to source in terms of supply chain. So get a problem and be smart about it and make an improvement out of the problem you have. And maybe to conclude then, since we are talking about next generation, the latest release of our car, Cybertruck, it's in Piazza 20 Settembre for the first time in Italy, already since tonight. That's how we didn't drive with it from Berlin, but it came here from Mars, and it's there waiting for you to see it. Get the chance, it's there until Sunday. And then, just because it's you, there was a message from Elon saying that the Tesla Robotaxi, so our cheap full self-drive car, will be unveiled on the August 8th. But if you are interested and want to learn something about it before, I suggest you scan the QR code.
Yes, take out your phones and scan the QR code. It will bring you actually to forms. You can fill out the form. We would love to stay in touch with all of you. And once we are going to be back in Berlin, we would like to actually get back to you and find a suitable opportunity, depending on what you're looking for, what your background is. And we would be happy to have a conversation with each and one of you. And hopefully one or many of you will become our colleagues in the near future. All right.
Yeah, that was the end of our presentation. We, of course, are here for your questions, but thanks you for your attention.
We will stay here for a few more minutes. We do have some time. If you want to ask us any question, feel free to do so. If you feel more comfortable asking in Italian as well, feel free to do so. We also have some pens or something for whoever is asking a question, if you want to as well. Thanks for passing the mic.
I have a question for so Tesla is known to be quite an unconventional company. Okay, what's the most unconventional approach to manufacturing that you came across during your time there? With respect to your studies, the most innovative thing?
That's a very nice question. I have an electrical engineering background, and most of the manufacturing is associated to mechanical studies. So I could kind of get surprised to everything when I see even the simplest machine. That's still pretty cool for me. But one thing about manufacturing Tesla is really proud of is what I was describing with the drone video of this unboxed design process. So it's 100 years that cars are made by joining piece by piece. And when you put the door, then you paint the car, and then you take out the door because you need to put the seats in. And this approach that Tesla has, it's quite different. Introducing the Giga casting, for example, that replaces 100 components, and it's inspired by the little Hot Wheels that is basically just one thing. You can't really scale that, but we asked who can make the largest press, and some guy said, yeah, I think we can. And that's how something that was 100-year-old valid true process got just flipped over, and now many others are doing it. And that's how progress works. So that really impressed me, how also on the manufacturing, which is something I had no idea about before, Tesla is really changing the game. And you need to do it when you want to get the volumes we are at, because reducing footprint, cycle time has an incredible value. You said Tesla is unconventional, so I pick up on this one to add something else. What I did not expect at all, although I heard it before, is that if we have a good idea that I had as an intern, it doesn't take much to bring it to the production. Everybody gets heard as far as you have data supporting your theory, which we have because the fleet is all connected. So our design is not done based on what we think the users are doing, but what the users are really doing. And that's quite an advantage. I think it was a good question, so we should give him a pen. I think we officially have 10 more minutes if you have more questions. Over there.
Sorry.
There was a one before last row. Yeah, you.
Can I? Sorry.
Okay. The mic is here. We go here and then we go there. Okay.
Okay. Hello. I have a question, especially about working on Tesla. As per the last diversity report that Tesla launched, I don't know if there was another one before, but in 2020, 2021, according to the numbers, only less than 4% of the workforce in management positions were Black, and about 83% of the management positions were taken by white males. And unfortunately, we didn't talk much about diversity and inclusion, but I would like to know if Tesla, since the previous agreement in 2021 to increase diversity and inclusion, had any improvement in these numbers, or if the company is doing something actively to balance the gender gap, especially considering that you guys are working on Europe, where we have legislation about gender balance.
Yeah, thank you very much. It's a very good question and also very important for me personally, to be honest. It's a very important topic. I don't have numbers now for you to tell you, to be honest, not by heart. But what I can tell you at Giga Berlin, we are a very international team with people from all over the world, really from all over the world. Do you remember how many? It was said once, but I forgot the number right now. Nationalities, more than 70 for sure. And yeah, so I really loved it about Tesla as well, that it's very international, and also English is a very important language. Not everyone has to speak German. So we try to improve it, but I cannot tell you any numbers right now, to be honest. Yeah. Next question.
Okay, I will try in English. How is the environment in Tesla, in the working environment in Tesla like? And also, since we're talking about Gigafactories, how much important the single person, single engineering specialist is with you? Is like? Okay, thank you.
I didn't get the last part. If you want to, maybe, did you get that, Mattia?
Yeah, like because we are many, does everybody count? Kind of.
Okay. I can take this one. Also a very nice question that is asked very frequently by our candidates, I would say. Our culture, although we are at least in Giga Berlin, right? We are already 12,000 people. And you can imagine that in the world we are like overall more than 100,000. We are lots of people, but at the end of the day, we somehow consider the environment as a startup, I would say. As Mattia was saying before, independently of the fact that you're an intern or a senior manager or a director, as long as your ideas are good and you can provide some numbers and you can show that you can implement that, it doesn't matter your job title or the seniority, you can just get things done. And I think that's the things that we love the most at Tesla, or at least the people that join and stay. If you are the person that likes to get things done and see the results as well quite immediately, you are really heard. Another thing I would say, again, we are very international, and if you love being among international people, yeah, we have several nationalities. You can as well approach whoever in the company. They're extremely friendly. You can also see that we are wearing a t-shirt and sneakers today, and yeah, we are also extremely friendly. Everybody is coming to the office like this. We are extremely relaxed, and you can have whatever kind of conversation with anybody. So I would say the culture is, yeah, very young, fresh, friendly, with lots of ideas, and I think we really love being there. Was there anything else?
No, maybe just like also to add, it's you hear a lot the companies advertising, it's a young and dynamic work environment. It's nice said words, but in some cases it's more true than others. I think we represent a young and dynamic work environment, so we stand by this, and it makes it quite fun. You saw a picture of our team. I'm 32, I'm middle-aged for the team. We have from interns, like right after university, 22, 23, and the oldest is like pretty much my age. So it's very young. We have a lot of perks, a lot of fun stuff. So we have graffiti all over the walls. What else is cool? Yeah. We have a coffee robot when you enter that makes coffee. You can work on a standing desk while cycling on a bike. You name it. It's pretty cool. Squadra corse.
Maybe I do have an off-topic question, but I do also have an electrical background. Even though I'm in Squadra Corsa and in the powertrain division, I'm into like renewable energy and stuff. In the Gigafactory in Berlin, do you only produce vehicles, so automotive, or do you also produce the power pole or the solar panels and stuff like that?
Model Y with the 6,000 rate a week so far. There was no Giga 3 years ago. I can't tell you how it's going to be in 3 years. But if you're interested from the design perspective, you can work on the energy products in Germany, in Giga, and we have also another site in Freiburg, in the south of Germany. That's the design part. Manufacturing, yeah, happens elsewhere. At the back.
Hi. I have a question regarding your battery type. So I have heard the news of 4680 battery type. So is it in production? And also the follow-up question regarding is like, how is compared to the other battery types like aluminum air battery and like silicon air batteries, and compared to 4680, like how it's more capable in terms of its efficiency, efficacy, and how it performs regarding its energy density and specific energy density?
That's a very good question. In the interest of time, I suggest you check out on YouTube a presentation with Elon and previous senior vice presidents where they introduced the 4680. They do describe how it compares with the other battery technology, how much more energy density is, and what is the advantage we have by using it in some of our products. And yes, it is in production.
My question is similar to the previous one. Is Tesla considering other technologies like zero emission technologies such as hydrogen, or also for as regard solid state batteries and technologies like that?
I think the best answer you can find is by scanning the QR code, because that's as much as I can tell you today. How many more pens do we have? We have 2 more pens. That means 2 more questions. And yes, sir.
Do you think in the future there will be a Tesla plant in Italy?
I'm afraid I'm not qualified to answer these questions. I read in the news something about it, the same as you might have read. Lea presented our current Gigafactory plans. You can do some math in terms of volumes needed and volumes per factory and try to speculate, but one last one. One last pen. Who wants the last pen? Is this a Tesla head? Yeah. Nice.
Actually, you have a 24 hours production in Berlin, in Giga Berlin.
It's different per shops. It's different depending on time.
24.
It
24/7.
It can be, yeah. Depends on the shop, depends on the time.
Okay. Sometimes. Okay. Yeah, it's 1,000 cars each day, no?
Also, our weeks have 7 days, and we make 6,000 a week.
We have no more pens, but if you guys have any other question, feel free to ask. Otherwise, yeah.
Yeah, we're right on time.
Not sure if we still have a minute.
Thank you again, I guess.
Yeah.
See you next year, and please apply.
Thank you.